Hello my friends, how are you? Sailesh sir here. Today we are going to discuss a very important chapter from physics, work and energy from class 9. The name of the chapter is work and energy. So let us discuss this chapter to the point with necessary detail. Now, what is work and what is energy? You know, for doing work we need energy. And with help of energy we create the force, and by force we can do the work. We can push the object or we can pull the object. We can do different work by applying energy only. Whether you say it energy, and when energy is converted into this, result will be force, and force will be converted into this displacement, which is known as work done. So what is this energy? It is the ability to do work, or it is a capacity of doing work by an object. Capacity of an object to do the work is known as energy. Then what is work? Work. When work is said to be done, when you say the work is done, in physics, when any object is displaced by applying some external force, then it is said to be work done. Mind well. So if any object is displaced by applying some external force, then only it is said to be work done. It means if it is not displaced, though you apply the force, and if it is not displaced, then work done is zero. Mind well in physics. If you apply the force, but this your object is not displaced, then work, no work is done. No any work is not done in the terms of physics. Mind well, not in our daily life. So there are two conditions of this result of work. One, we must apply the force on the object, and we must get the displacement of the object as a result. If we don't get the displacement, object is not displacement, the work done is said to be zero. Mind well. So here the best example is your moving fan. In this physics this term, though your fan is moving around in circular path, around the fixed position, fixed point, you know, it always comes, as it is in circular motion, comes from one point to the same point. So there is no displacement. Displacement is zero, though it is doing the work for 8 hours, 10 hours, 12 hours. Constantly it is moving. Constantly it is doing the work of giving us this cool air. But in physics, the displacement from the origin position to final position is zero, because it comes back to the same position. So the work done is zero. What a surprise. This is the definition of this physics, my friend. But in our day-to-day life, we will say a lot of work is done. It has run. My fan has run for this 10 hours, 12 hours. And more it is running, more hours it is, your bill will be also higher, you know, because more electricity it will consume when it is used for a long time, more time, you know. So this is the difference in your this day-to-day life concept and this physics concept. Here we have to learn the physics concept. So though in our day-to-day life this working of your fan is not zero, mind well, but in physics it is said to be zero, as it is in circular motion, because displacement from one point to other point is zero, because after finally it comes to the same point when it is moving in circular motion. Okay, so this is the so when any object is displaced by applying some force, then it is said to be work done. It means if the displacement is not done by applying force, then the work done is said to be zero. Okay. So now energy. So you know this, without energy we can't do the work. So what is energy? The capacity of doing the work by an object is known as energy. In other words, if this ability of the object to do the work, ability of the object or body to do the work is known as this energy. And the result of this work, when you can say the work is done, if only if this object is displaced from this original position to other position, one point to the other point. Otherwise not. If it comes back on the same position after doing lot of effort, then your work is done zero in physics. So okay. So don't get mixed up this day-to-day life sense and the sense of physics, because their concepts are in a little difference with respect to scientific definition, scientific concept to study it. So they kept that they define their concept in different way, maybe separate from, maybe different from your day-to-day life view. Okay, no. Now, so work and energy we have done. Both are interconnected. Both are the same. This two sides of the same coin. The energy is applied, the result is work done. Energy, same way like force and they are also this pair is force and energy are this same part of two coin. If energy is applied, force is applied, the result. And if energy and force both are applied and the displacement is done by with help of force, then the work is done. All are interconnected. Energy, then it is converted into force, and the result of force is converted into this work. If body is displaced, mind will, but generally it is displaced in general majority case. When you push any object or pull any object, it is displaced. Displacement will take place by using more force or less force, or more energy or less energy. But the source of all this force and work is the energy, With help of energy only this force is produced, and with help of force only this work is done. This is the basic concept. Now the next point is types of energy. There are many types of energy like light energy, electric energy, magnetic energy, chemical energy, heat energy. So there are lot of type of energy, but which are the fundamental types of energy from which all these type of energy is converted? So there are in physics there are two fundamental type of energy. Which one is kinetic energy and one is this our potential energy. Before that, this universal law of gravity, this universal law of not we are talking about, but this law of conservation. The law of conservation of this energy. Law of conservation means this storing of energy. So what is the law of conservation? Energy neither can be created or nor can be destroyed, but it can be only transformed from one form to another form. The total amount of the energy remains same. It is only just converted from one form to another form, but it can't be destroyed or can't be created. Much more. The total energy remains same. So this law is known as conservation of this energy. Most important law of conservation of energy. Not the law of this universal law of this gravitation. We are not talking about it. Here there are so many similar definitions with use the word conservation, but all items are different mind way. Okay. So here we have to use this conservation. Energy neither be created nor can be destroyed, but only it can be transformed from one form to another form. And the final the total energy before transformation and after transformation remain the same. Total energy. This is known as law of conservation of energy. Okay. So this kinetic energy and this potential energy can be converted into different type of energy. This like this electric energy, light energy, all this type of energy. But total quantity of this amount of the energy used remains same before this consumption and after its consumption. This is the law. Okay. So here, what is kinetic energy? What is this potential energy? From which all this energy, directly or indirectly, coming from these two sources, these two basic forms, kinetic and this potential. Let us see. The kinetic energy what? The energy due to this virtue of motion of the object. Energy possessed by the object due to motion. it is known as kinetic energy. You know, the object is going with the more speed, will have more force, and more energy force, and this object going with the less speed will have less force, less force, and it will have got less effect, and this speed will have more effect, more result. So this, you know, this due to this motion of the object, it possesses energy, that is kinetic energy. So when you will say, so when it stopped, what happened? This kinetic energy is destroyed or disappeared. So here, my friend, this same kinetic energy, when this moving object comes to stops and rest, then this same kinetic energy is converted into potential energy. Potential energy is the energy stored within the object and or body. So again, when you restart, so again this potential energy will be converted into this kinetic energy. Because so best example is our body. So our body has got potential energy when we are resting. But when we stand up and keep walking, so this potential energy is converted into this kinetic energy. So you will have the more and this force, but there's more force due to your motion compared to your sitting. So this is the law. So when you when two cars are collided with more speed, they will get more damage due to their kinetic energy. And when they collide with the less speed, so they will have the less energy. So they will have less damage. Mind well, this is due to their action and reaction force. Acting and reacting force are equal and in opposite direction. All laws are interconnected, my friend. They are connected with energy. No, okay. So they are all interconnected. So here this work done always depend on the energy. Okay. So what is work done now? What is work? You know, the formula of work. So force into displacement. You know, for doing work we require force, and also we require the result of this force as a displacement of the body. If it is not, the work is said to be done zero. So force into displacement. The formula of the work is force into displacement. Okay. And what is energy? The energy is the ability or capacity of doing work. Without energy we can't do work. The ability to do work or this capacity of doing work by an object is known as energy. So energy and work both are the two different sides of the same coin, like this force and energy. Okay. So energy is the source and the work is the result. In force and energy is the source and force is the result. And all the three if we put together, so the work is the result of energy which is converted into force, and result is work. Same. Okay. So don't get confused. Okay. But remember this basic concept. All these are interconnected form of energy. Okay. So now what if kinetic energy we have seen this due to this motion. So what is the definition of potential energy? So energy lying within the body. When it is resting, there is energy. It is not without energy, our body. It is within our body. And when we stand up, then this energy is converted into this kinetic energy. That's why we are able to walk and do the work due to our potential energy. If it is not potential energy is not there, so we can't do the work. We can't convert this into kinetic energy or any other energy. Okay. So this is the potential energy, the energy lying within the body. Energy lying within the body. Due to this is the general sense definition, the fundamental definition. But in your 9th standard physics, in the sense of physics, the definition is like this: this energy possessed by possessed within the body of the object due to its position and shape. Due to its position or shape is known as this kinetic energy. They have used two words added. This energy lying within your body depends on two items, two things. Whether your energies will be more or less. So it depends on your this position, where your body is situated, object is situated, at more height, less height, or on the ground. So that is on the situation, and that is position, known as position. And second virtue of this object is due to its shape, particular shape here. For example, spring is a particular shape. So when you pull the spring with more force, and if you leave it, so it will come back with the more force and towards the backward direction, opposite direction. Okay. And same way, you take the rubber band, and the more you pull, and if you drop, this leave the the other end, so it will go with very too much force and strike to your hand or this your fingers, with, and can damage you, because more you pull, this reaction of this going back will be more, with more force. This here the third law is involved also. The action and reaction are always equal and in opposite direction. Means acting force and reacting force are equal and in opposite direction and of the same value. And of the same value. Okay, more you pull, the more you will be, it will be rebound back. Less you pull, it will be rebound back less, proportion to this action. Okay. So this is the clear concept of this fundamentals of this chapter. Now you know what is kinetic energy due to motion, and what is potential energy lying within the body, but due to its virtue of this position or its shape. Okay. So now the third one. So how much this work, this energy is used to do the work? More it is consumed, then you can say it is using more power. Your electricity bill. So more electric energy is used, so it will consume more power. And less electric energy is consumed, then it is less power. So energy consumed in unit time, energy consumed or energy transformed, energy transferred in unit time is known as this power. So power equal to this energy transferred upon time. Energy transferred from one point to other point, or consumed from one point to other point. It said work done. How much energy consumed means that much work you will do. More energy is consumed, more work will be done. And less energy is consumed, less work you will do. So the final this formula of this power P equal to this work done divided by time. Here time is unit time. So rate of work done in unit time is known as power. Second one, instead of work we can use also energy, because of work is the form of energy. Second, the same form of the same coin, two form of the same coin. So energy consumed or transferred in unit time, rate of energy transferred in unit time is known as this work. Or instead of energy you can use the word work, rate of work done in unit time, because work and energy are the same thing practically, because without energy you can't do the work. Energy is the source and this work is the result, Okay, so the final this formula will be power P equal to the work W upon time T. Work upon time, work done in unit time. Or if you don't want to use the work, then energy transferred in unit time, or energy consumed transfer. When you transfer from one point to another, that is displacement of the energy, that is work. That is work done, displacement. Okay. So here this power is measured in this Watt. Mr. James Watt, he measured all this electric power in a different power unit. In the memory of scientist this James Watt, the unit of this power consumed, this is known as Watt, W-A-T-T. W-A-T-T is the pronunciation is Watt, not W-H-A-T, my bad. So this is the power, and our electric bill in India comes in this 1 kilowatt per hour. How much watt is used? 1 kilowatt means 1000 watt. 1000 watt used in per unit time means here unit time they have taken 1 hour. So this, if you consume 1000 watt this kilowatt, so 1 unit bill will become 2000 this kilowatt per hour in 1 hour fixed time unit time. Then your bill power, this your bill will be 2 unit. In your bill will, the amount of bill will be higher if you consume during the month. If you consume that 100 unit, instead of 100 unit, if you consume 200 unit, then bill will be naturally, amount of the bill will be more. More you consume, more amount of bill, more amount of money you have to pay. Because here the power is electricity, and transfer of this electric power, electric energy, that is electric energy power. The basic thing is energy from your powerhouse to your home, that is transfer, displaced from that, the work done. Okay, so the transfer of electric energy, and whatever transfer we are getting this electricity for our use, it is consumed. Whatever energy transferred or consumed by us, this then it is known as power in unit time. Okay, so this is the fundamental of this power. Its a unit is joule. And what is the unit of this work? Here unit of this power is watt. And what is the unit of this work? What done? This displacement of body by applying force. So what done? That unit is given by Mr. Joule in the memory of Mr. Scientist Joule. That is Joule, Joule. Joule. Joule is the unit of work, and this watt is the unit of this power. Power is the rate of work done in unit time, and work is simple. There is no rate. The work done. And there is no mention of time. So this only work is done. Then it is known as this joule. And this joule, the formula of work F into S, force into displacement. Okay, and this formula of this power is this work upon time, or energy transferred upon time. Popular formula is work upon time, work done, that is energy consumed or done. Okay, so the last part of your chapter, the point, fundamental concept, that is what is mechanical energy. So mechanical energy is nothing, according to your science textbook, the sum of the, sum means addition, sum of the this potential energy and kinetic energy is known as mechanical energy. Total sum of this mechanical energy and this potential energy and kinetic energy equal to mechanical energy. So your mechanical energy is nothing, it is the result of the this combination of this kinetic energy as well as this potential energy, because kinetic and potential energy always go parallel. When potential energy is used, it is converted into kinetic, and when kinetic energy means energy of motion is stopped, it is converted back into potential. So for this mechanical energy, both are required. Kinetic, because all these machines are rotating, kinetic, and when they stop, and again they will have the potential energy. So due to this potential energy, when we restart again, they will start moving or rotating due to its potential power, potential energy. They are interchanging frequently this potential to kinetic and kinetic to potential. That's all. Bye.